Okay, so before I start something new, do we have questions that need to be done from the previous worksheets? No? Determinants and inverse on 2x2 matrices. Both of those are okay? Yeah? Okay. So now, if you remember, last week I said that we have another method for solving simultaneous equations, for solving two equations together. So let's just recap the methods we have so far. We have graph. What else do we have? Substitution, that's 2. Elimination.
Gaussian.
And Gaussian, that's 4. The fifth method is using matrices, the matrix method. Okay, so that's what we're going to look at now. Okay, so firstly, to get us started, let's have a look at this multiplication. Matrix, square matrix with ABCD inside it, times XY equals PQ. So let's multiply that out. So as you know, AB times XY, AX plus BY, equals P, and then next
CX plus
yeah,
DY.
that would be CX plus DY equals Q. And really the point I'm making here is that this matrix multiplication actually is pretty much identical to these two equations. So if I give you these two equations, it's the same as giving you this one matrix multiplication here, or vice versa. So the idea is, if I now just scroll down to here, that if you see this problem, you can write it as matrix multiplication. Look carefully here. This is a square matrix, this is XY, this is PQ. So I'll call this square matrix A. I'll call this matrix here capital X, and I'll call this matrix here B. So really, when we say we want to find X and Y, what we're really trying to find is this X here. Okay. Okay, so like I said, trying to find X and Y here is basically the same thing as trying to find this X here. So let's see if we can make a formula to find that, and we can actually, and it's not very difficult. So this is the proof, so to speak, of how to find the formula. We want the X here. We don't really want this A here. So any ideas on what we should do to both sides to get rid of the A?
Divide by A.
Yeah, now normally in algebra I can just take A to the other side, but I can't really do that here.
Multiply by A inverse.
Yeah, I need to multiply by A inverse. Now please remember, the order is important. So if the A inverse goes in the front here, then it must go in the front here. And if I put at the back, then it must go at the back. So in fact, I am multiplying both sides by A inverse, but to be more precise, I'm pre-multiplying both sides by A inverse. In other words, I'm putting A inverse at the front of both sides. Now that's great, because what's A inverse times A?
I.
Yep, it's just going to be I. And then what's I times X?
X.
X, yeah. So this is, in fact, is our formula. That our answer X, what we want, is equal to the inverse of A multiplied by B. So we'll have a look at an example now using this. Do you need me to scroll up? Yeah, to here maybe? I'll scroll down a little bit now. Okay. Okay, so let's have a look at an example now. New page. So for example, I say solve 9x plus y equals minus 7, and then 8x plus y equals minus 8. So the first thing you need to do is write this in matrix form. So that would be, for example, here 9, 1, 8, 1, xy equals minus 7 minus 8. And if you can't quite see, that number came there, the 1 was the number in front of the y here, the 8 was the number in front of the x here, and the 1 was in front of the y here. The x and y because it's x and y here, and then 7 and 8 goes there. So in other words, these four numbers are the four numbers here on the left, and these two numbers here are the two numbers here on the right, and x and y because it's x and y here. Now we can use our formula that I just showed you. The answer, x and y, is equal to the inverse of 9181 times minus 7 minus 8. This shouldn't be any problem because we spent last class doing inverses. So inverse here, first thing, 9 times 1 is 9, 8 times 1 is 8, 9 minus 8 is 1, and 1 over 1 is 1, so the piece in the front is just 1. And then I swap these and minus these. Yeah, minus 1 minus 8. And then that just gets multiplied there. Okay, 1 times minus 7 is minus 7, minus 1 times minus 8 is 8, minus 7 plus 8 is 1. Minus 8 times 7, what's that? 50. Plus, no, minus 72. So what do we get there? This maybe is calculator time considering how early it is. In total? Oh, sorry, this is a positive and negative is positive. I won't do it in my head, I'll just write it down. Okay. 1 times minus 7 is minus 7, like we said, and then minus 1 times minus 8 is 8. And then, yes, what's next? Plus or minus? Plus, yes, and then next? Plus or minus? Minus, yeah, 72. So that would be a negative number. Okay, and that would be positive. What is it? 16 minus, okay. I think somebody said 16, but I might have heard 64, which I knew would have been wrong. Okay, and then the 1 in the front there is just multiplying by 1, which doesn't do anything. So that's the x and that's the y. X is 1, y is minus 16. The advantage of this is that it only really took me 2 lines to do. Okay, so it's not too long. I'll do another example here once you have this taken down. Scroll up. Well, this is the question here. But that's actually just the first question there in the book, so you only really need kind of from this part. Yeah, go down a bit. Okay, another example now. So what about something like this one? Y equals minus 4x minus 5, and then y equals minus 5x minus 8. The problem with this is that it's not quite ready for me to use matrices yet, because the x and y aren't with the y. This is on the wrong side. The x and the y needs to be together on the same side. So before I start, I have to take these two here to the left. And I get 4x plus y and 5x plus y equals minus 5 equals minus 8. Now, because the x are lined up and the y's are lined up and the numbers are lined up, now I can write matrix method in. So here I get 4, 1, 5, 1 xy equals minus 5 minus 8, or just take this over to the left, so to speak, 4, 1, 5, 1 inverse, and let me get rid of this now. And now I just invert and multiply. So that would be, let's see, 4 minus 5 is minus 1, 1 over minus 1 that is, which is just minus 1. Swap, change the sign, and then I have to multiply by these two here. Let's see, 1 times minus 5 is minus 5, minus 1 times minus 8 is 8, 8 minus 5 is 3, but 3 times minus 1 is minus 3. And then minus 5 times minus 5 is 25. 4 and minus 8 is minus 32. So 25 minus 32 is minus 7. Yes? Minus 7 times minus 1? 7. So that's the answer there to that one. So if you write this one down, please. Yes? Say again? What do you mean swap? Shh, hey. I'm not sure what you mean by swap. What numbers do you think? Here? Let's see. What I did was I swapped 4 and 1, so that makes 1 and 4. And then I minus these ones, minus 1 and minus 5. So that was the only swap I made, just one swap. And then I multiplied here to get these two. Is that okay? Okay. Let's see now. Okay, maybe we'll do one more here. Do you have this taken down? Yeah? Okay, so one more example here. Okay, minus 8 over 3 x plus 9 over 8 y equals 2 over 3, and then here minus 8 over 3 x plus 6 over 5 y equals minus 8 over 3. Okay, so like before, using the matrix method, I can jump straight to the answer. Xy equals minus 8 over 3, 9 over 8, minus 8 over 3, 6 over 5, inverse, times 2 over 3, and 8 over 3. And I'll happily take a calculator off of someone to do this one. Thank you. Okay. Right, so firstly, the part I don't need a calculator for is just the swap in the minus part. So that's 6 over 5 minus 8 over 3 minus 9 over 8 and 8 over 3. And now let me do the determinant part in the front. Minus 8 over 3 times 6 over... minus 8 over 3 times 6 over 5. Minus and minus make plus then, so plus 8 over 3 times 9 over 8 over 3 times 9 over 8. Okay, so 8 over 3, 6 over 5, 9 over 8, and 8 over 3. Okay, so that gave me minus 1 over 5, but it's 1 over that. So in the front here, I'll just get minus 5. Okay. Now back to the calculator for the next piece. Okay, 6 over 5 times 2 over 3 minus 9 over 8 times 8 over 3, which is minus 11 over 5. Eight over 3 times 2 over 3 minus 8 over 3 times 8 over 3. 8 over 3 times 2 over 3 minus 8 over 3 times 8 over 3. Okay, not quite as nice for the next one. Minus 16 over 3. Yes, it doesn't have a nice answer. Okay, last thing to do is to multiply in this minus 5. So on the top, I'll get, what will I get on the top? It'll just be 11, because minus and minus make plus, and the 5 cancel the 5 here. And then here, minus 5 times minus 16, so what's that, 80, isn't it? Over 3. Minuses again cancel. Whoops. Okay. See, it gets a little bit messy with fractions, but it works really nice for like the first one here I did, where you have whole numbers as the coefficients, and also something very nice happened with the first one here. What was the determinant here? 1, so it meant no fraction was made there. So sometimes it works really, really neatly. You want me to, this part? Up further? Okay. Here? Okay. Yes.
Here you swap, then you get this determinant again. Not the other way around.
The determinant should come from the original, not from the part that's swapped. Did I make a mistake here?
Yeah, you swap.
But maybe I swapped here, but maybe I used the numbers for this part from the original. I'll double check that, but anyways, yeah, in case somebody was confused by that, this determinant part here must come from the original, not from this piece here. I'll just double check that. I'm pretty sure I did that. Minus 8 over 3 times 6 over 5 minus 9 over 8, and then another minus makes a plus. 8 over 3. Yeah. So, you're right, I should use the numbers from the original before I swap or change the sign. Yeah.
But they still be the same,
I don't know if it gets flipped if you calculate the determinant after you do the inverse part.
All you do is switch the places of B and C, and then make the...
Oh yeah, it'll actually, yeah, you're right, it would be the same because you just switch the first two, so it's just, instead of AD, it's DA, and then the minus is cancelled, yeah. So in fact, it doesn't matter. You could use either one. Okay, do you all have that taken down? Yeah? Okay.